I will tell you in 5 lectures the chemical history of a candle. There is not a law under which any part of the universe is governed which does not come into play and is touched upon in the chemistry of a candle. There is no better, there is no more open door by which you can enter into the study of science than by considering the physical phenomena of a candle. I trust, therefore, I shall not disappoint you in choosing this for my subject rather than any newer topic which could not be better were it even so good. So, now as to the light of the candle. Notice that when the flame runs down the wick to the wax, it gets extinguished, but it goes on burning in the part above. Now, I have no doubt you will ask, how is it that the wax, which will not burn of itself, gets up to the top of the wick where it will burn? We shall presently examine that, but there is a much more wonderful thing about the burning of a candle than this. You have here a solid substance, the fuel, with no vessel to contain it, and how is it that this can get up to the place where the flame is? How is it that this solid gets there, it not being a fluid? Or when it's made of fluid, then how is it that it keeps together? This is a wonderful thing about a candle. You see that a beautiful cup is formed. As the air comes to the candle, it moves upwards by the force of current which the heat of the candle produces. And it so cools all the sides of the wax as to keep the edge much cooler than the part within. The part within melts by the flame that runs down the wick as far as it can go before it's extinguished, but the part on the outside does not melt. The same force of gravity which holds worlds together holds this fluid in a horizontal position, and if the cup be not horizontal, of course the fluid will run away in guttering. You see, therefore, that the cup is formed by this beautifully, regularly ascending current of air playing upon all sides, which keeps the exterior of the candle cool. No fuel would serve for a candle which has not the property of giving this cup. These beautiful candles, which are irregular and intermittent in their shape, cannot have that nicely formed edge to the cup, which is the great beauty in a candle. I hope you will now see that the perfection of a process, that is its utility, is the better point of beauty about it. It is not the best looking thing, but the best acting thing, which is the most advantageous to us. These good looking candles are bad burning ones. There is guttering because of the irregularity of the stream of air and the badness of the cup which is formed thereby. You may see some pretty examples, and I trust you will notice these instances of the action of the ascending current when you have a little gutter running down the side of a candle, making it thicker there than it is elsewhere. As the candle goes on burning, that keeps its place and forms a little pillar sticking up by the side because as it rises above the rest of the fuel or wax, the air gets better around it and it is more cooled and better able to resist the action of the heat at a little distance. Now, the great mistakes and faults with regard to candles, as in many other things, often brings with them instruction which we should not receive if they had not occurred. We come here to be scientists, and I hope you will always remember that whenever a result happens, especially if it be new, you should say, what is the cause? Why does it occur? And you will in the course of time find out the reason. Then there is another point about these candles which will answer a question, that is, as to the way in which the fluid gets out of the cup, up the wick, and into the place of combustion. You see that the flames on these burning wicks do not run down to the wax and melt it all away, but keep to their own right place. They are fenced off from the fluid below and do not encroach on the cup at the sides. I cannot imagine a more beautiful example than the condition of adjustment under which a candle makes one part subserve to the other to the very end of its action. A combustible thing like that, burning away gradually, never being intruded upon by the flame, is a very beautiful sight. Especially when you come to learn what a vigorous thing flame is, what power it has of destroying the wax itself when it gets hold of it, and of disturbing its proper form if it comes only too near. But how does the flame get a hold of the fuel? Capillary action conveys the fuel to the part where combustion goes on, and it is deposited there not in a careless way, but very beautifully in the very midst of the center of action which takes place around it. Now, I'm going to give you 2 instances of capillary action. It is that kind of action or attraction which makes 2 things that do not dissolve in each other still hold together. When you wash your hands, you take a towel to wipe off the water, and it is by that kind of wetting or that kind of attraction which makes the towel become wet with water that the wick is made wet with the wax. If you throw the towel over the side of the basin, before long it will draw the water out of the basin like the wick draws the wax out of the candle. Let me show you another application of the same principle. You see this hollow glass tube filled with table salt. I'll fill the dish with some alcohol colored with red food coloring. You see the fluid rising through the salt. There being no pores in the glass, the fluid cannot go in that direction, but must pass through its length. Already the fluid is at the top of the tube. Now I can light it and make it serve as a candle. The fluid has risen by the capillary action of the salt, just as it does through the wick in the candle. Now, the only reason why the candle does not burn all down the sides of the wick is that the melted wax extinguishes the flame. You know that a candle, if turned upside down so as to allow the fuel to run upon the wick, will be put out. The reason is that the flame has not had time to make the fuel hot enough to burn as it does above, where it is carried in small quantities into the wick and has all the effect of the heat exercised upon it. There's another condition which you must learn as regards the candle, without which you would not be able fully to understand the science of it, and that is the vaporous condition of the fuel. In order that you may understand that, let me show you a very pretty experiment. If you blow a candle out carefully, you'll see the vapor rise from it. You have, I know, often smelt the vapor of a blown out candle, and a very bad smell it is. But if you blow it out lightly, you'll be able to see pretty well the vapor into which this solid matter is transformed. When I hold a lighted match 2 or 3 inches from the wick, you can observe a train of fire going through the air till it reaches the candle. I'm obliged to be quick and ready because if I allow the vapor time to cool, it becomes condensed into a liquid or solid, or the stream of combustible matter gets disturbed. Now, to the shape or form of the flame. It concerns us much to know about the condition which the matter of the candle finally assumes at the top of the wick, where you have such beauty and brightness as nothing but combustion or flame can produce. You have the glittering beauty of gold and silver, and the still higher luster of jewels like the ruby and diamond. But none of these rival the brilliancy and beauty of flame. What diamond can shine like flame? It owes its luster at night time to the very flame shining upon it. The flame shines in darkness, but the light which the diamond has is as nothing until the flame shine upon it when it is brilliant again. The candle alone shines by itself and for those who have arranged the materials. The flame is a bright oblong, brighter at the top than toward the bottom, with the wick in the middle. And besides the wick in the middle, certain darker parts toward the bottom where the ignition is not so perfect as in the part above. Now, let me show you. There's a matter rising about it which you do not see. You can actually see streaming around the flame something which is not part of the flame, but is ascending and drawing the flame upwards. There is a current formed which draws the flame out, for the flame which you see is really drawn out by the current and drawn upward to a great height. How remarkable it is that the thing which is light enough to produce shadows of other objects can be made to throw its own shadow. You observe the shadow of the candle and of the wick. Then there is a darkish part, and then a part which is more distinct. Curiously enough, however, what we see in the shadow as the darkest part of the flame is in reality the brightest part. And here you see streaming upward the ascending current of hot air, which draws out the flame, supplies it with air, and cools the sides of the cup of melted fuel. You know the flame goes up or down according to the current. You see then that we have the power in this way of varying the flame in different directions. Many of the flames you see here vary in their shape by the currents of air blowing around them in different directions. But we can, if we like, make flames so that they look like fixtures, and we can photograph them. Indeed, we have to photograph them so that they become fixed to us if we wish to find out everything concerning them. If I take a flame sufficiently large, it does not keep that homogeneous, that uniform condition of shape, but it breaks out with a power of life which is quite wonderful. In what way does it differ from an ordinary candle? It differs very much in one respect. We have a vivacity and power about it, a beauty and a life entirely different from the light presented by a candle. You see those fine tongues of flame rising up. You have the same general disposition of the mass of the flame from below upwards, but in addition to that, you have this remarkable breaking out into tongues which you do not perceive in the case of a candle. Now, why is this? You have the air creeping in over the edge of the dish forming these tongues. Why? Because through the force of the current and the irregularity of the action of the flame, it cannot flow in one uniform stream. The air flows in so irregularly that you have what would otherwise be a single image broken up into a variety of forms, and each of these little tongues has an independent existence of its own. Indeed, I might say you have here a multitude of independent candles. You must not imagine, because you see these tongues all at once, that the flame is of this particular shape. A flame of that shape is never so at any one time. Never is a body of flame like that which you just saw rising from the ball of the shape it appears to you. It consists of a multitude of different shapes, succeeding each other so fast that the eye is only able to take cognizance of them all at once. They do not occur all at once. It is only because we see these shapes in such rapid succession that they seem to us to exist all at one time. We have thus far spent our time considering the light of the candle, discussing how the fuel gets to the wick and the form of the flame upon combustion. But we have more questions to ponder. From where does the brightness come? And where does the candle eventually go? And in a larger sense, how do the products of combustion lead us to a discussion of the atmosphere? And what is the relationship between combustion and respiration? I started this lecture by claiming that there is no more open door by which to enter into the study of science than by considering the physical phenomenon of the candle. Over the next 4 lectures, I hope to prove this to you.